For a moment, think about what would be humanity's greatest discovery. For astronomy lovers, the answer would surely be unanimous. Is there life beyond our planet? Now imagine how we might get the answer to such a question. What if that discovery wasn't an alien skeleton or an abandoned spaceship, but something much more subtle, and perhaps for that very reason, much more profound? A rock. A simple spotted rock found on Mars, which today may be the strongest candidate we've ever had for the first proof of life beyond Earth. This story begins a few weeks ago in a carefully chosen location on Mars, the Jezero Crater. Billions of years ago, this was not the arid, frozen desert we see today, but an oasis. A vast lake, fed by a winding river system, formed a sediment-rich delta. It is in precisely these kinds of places, ancient muddy lakebeds, that life on Earth flourished and left its first signatures. That is why NASA sent its most advanced laboratory on wheels there, the Perseverance Rover. Its primary mission? Astrobiology, the search for signs of ancient life. While exploring a region named Neretva Vallis, the bed of an ancient river that flowed into the lake, it found a common-looking rock, a type of sedimentary rock called mudstone. With its robotic arm, Perseverance drilled the surface and extracted a small rock core, the size of a piece of chalk. But when the high-resolution cameras sent the magnified images back to mission control on Earth, a hush of astonishment fell over the room. The rock's surface was covered in a mesmerizing pattern. Dozens of small, dark gray circles, each surrounded by a lighter, whitish halo. The pattern was so distinct that scientists immediately compared it to petrified leopard rosettes. It wasn't random, it was organized, and most shockingly, it was incredibly familiar. Here on Earth, practically identical formations are found in oxygen-free environments, like the mud at the bottom of lakes or swamps. They are created by colonies of microbes that, in the absence of oxygen, developed a spectacular biochemical trick. They breathe minerals. In a complex process, these microorganisms transfer electrons using iron and sulfur compounds, altering the chemistry around them and leaving behind these mineral scars as proof of their existence. And here comes the breathtaking part. The NASA rover's instruments didn't just see the pattern, they analyzed its chemical composition. They found the exact minerals associated with this process on Earth, such as greigite and vivianite, intimately linked with organic molecules, the building blocks of life. Scientists call this the combination of the holy trinity of a biosignal: the right minerals, the right spatial arrangement, and the presence of organics. All of this, together, in a rock formed in the mud of an ancient Martian lake. But science demands skepticism. Before we declare the discovery of extraterrestrial life, we must exhaust all other possibilities. Could it just be a trick of chemistry? NASA itself is the first to urge caution. Certain purely geological processes not involving life can also create similar patterns and minerals. Organic molecules, for example, can be brought to Mars by meteorites. Chemical reactions in hydrothermal vents or in highly acidic water environments can also produce minerals like greigite without the help of a single microbe. Nature, at times, is a talented mimic. That is why, for now, NASA classifies this find as a potential biosignature. It's a smoking gun, perhaps the strongest we've ever found, but it is not yet definitive proof. So how will we get that proof? The answer lies in one of the most ambitious projects in the history of space exploration. Perseverance sealed this sample, named Sapphire Canyon, in a sterile titanium tube. This tube, along with others, was left in a depot on the Martian surface, like a message in a cosmic bottle, waiting to be collected. The Mars Sample Return Mission, a colossal joint effort by NASA and the European Space Agency, ISA, planned to send a new spacecraft to Mars starting in 2027, is not confirmed. This means that what could be one of astronomy's greatest discoveries might not be analyzed at all. At least, not for now. And if the possibility of finding life beyond our planet piques your interest, watch the video in the card above and discover an exoplanet showing signs of being one of the most promising candidates for harboring life outside our solar system. Returning to the samples collected on Mars, if NASA does manage to bring them to Earth, it can then use our planet's most powerful instruments to perform the final tests. Scientists would look for unmistakable evidence, microfossils of cell walls, ratios of carbon isotopes that only biological metabolism produces, and the ultimate test, chirality, the search for the left-handedness of amino acids, a chemical signature that, as far as we know, only life can produce. So are we looking at a fossilized echo of Martian microbes that breathed iron in the calm waters of Jezero Crater billions of years ago? Or are we witnessing an elaborate chemical theater, a cosmic trick meant to deceive us? For now, the answer is sealed in that titanium tube, waiting silently on the red soil of Mars. But one thing is certain. If that rock ever reaches Earth, it has the power to redefine forever what it means to be alive, and whether or not we are alone in the universe.